Good morning, students.
Good morning, sir.
What happened? You came late today? Okay, today is Sunday. So, no problem. 2-3 minutes here and there. All right. So, let's see what we were doing in last class around. We solved certain problems in which the blocks or the masses were connected horizontally. How to get the tension and acceleration we learned. Then we connected the blocks vertically. In the last class, we discussed about the blocks are connected vertically and we found again tension and acceleration for those. Today, we are going to see when the blocks are connected with the help of a pulley. Then what is the acceleration and what is going to be the tension. Okay. So now with the pulley, we call it as pulley block system. Right. Sorry. So this is pulley here and it's fixed. Pulley is not going anywhere. On the two sides, two blocks are there. This is block 1 and here is block 2. Its mass is m1, its mass is m2. Let's assume m1 is greater than m2. And this is the system. Okay. Now, since m1 is greater than m2, what will happen? m1 will go down and m2 will go up. But before going to that, let's make this free body diagram. So we know that here gravitation force or weight is acting, which is m1g. And at this point here, there will be tension upwards. Directions how to take, you already know. At any point, direction of tension should be such that at that particular point, it should be trying to decrease the length of the string. Okay, so tension is upwards. In this system, pulley as well as string is massless. Pulley and string are massless. Remember, unless it is given in the question, both are massless for us. If they specifically give, then only mass you take. Otherwise, we'll be taking it as massless only. Okay. So this is m1g, here is T. Same way, let's make for this also. This is m2g here. And tension. Okay. And as we said, m1 is greater than m2. That means m1 will be going down. So if m1 is going down, let's say with acceleration a, this will go up with the same acceleration because they are connected with the same string. This is going up. Okay, now let's write the equation for this one. Then we'll write equation for this. So in this one, what is resultant force? It is going up. So, sorry, it's going down. So obviously m1g is more than T. That's why it's going down. So what is the resultant force? m1g minus T. Right, m1g minus T is the resultant force is equal to mass into acceleration. For that, we'll write in this one, it's going upwards. So obviously T is greater than m2g. That's why it's going upwards. So we'll write resultant force is T minus m2g equal to m2a. Both equations we have to have. And from these equations, we have to get tension as well as acceleration. So let's solve them. So I'm going to add it. Just add these two equations. So when you are adding, you can see that this minus T and T. Okay. When you add T and minus T, it will become 0. What is remaining? m1g minus m2g. So m1g minus m2g. On the right hand side, what is there? m1a plus m2a. m1a plus m2a. G you can take common. It's m1 minus m2. Here a we can take common. It's m1 plus m2. So acceleration which is coming is m1 minus m2 g by m1 plus m2. We can remember this is a formula. Okay. Acceleration is m1 minus m2 into g by m1 plus m2. That means the heavier mass weight minus lower mass weight by total mass. Okay. Then what we have to find? We have to find tension. So what you'll do, this acceleration value, we are going to put in any of the equations. Okay. So let's do that. Let's put it in the equations. So what we have, m1g minus t equal to m1a. So m1g minus t equal to m1 into a. What is a? m1 minus m2g by m1 plus m2. m1 minus m2 into g by m1 plus m2. Okay. Then you bring it here, take tension over there. m1g minus m1 g into m1 minus m2 by m1 plus m2 equal to t. When you solve this one, you are going to get 2m1 m2g by m1 plus m2. T value will come 2m1 m2 by m1 plus m2 into g. This will be tension. So again, if we can remember this, you can get the answer earlier. If you solve this much, obviously it takes time. But when the values will be given, even if you don't remember these two formulas, we can calculate fast when values are given. Here values were not given, m1 and m2 were there. So it took us time. But if values are given, even with this equations also we can calculate faster. But still, if you remember them, you can solve very fast. So note these two. Completed? Students, is it over?
Yes, sir.
Okay. Now let's do the problems based on that. That means we'll have the values of the blocks or the masses. Okay, so let's have question number 1. A fixed pulley. Here is block 1. Let's say its mass is 5 kg. And another one is here, this is 3 kg. Okay. Find acceleration of masses and tension in string. Acceleration of masses and tension in string. That's our question. Okay, so directly can apply the formula. What are the formulas? First, our formula is for acceleration. Acceleration is equal to weight of heavier body. Now, weight of heavier body is this. So, weight of this is 5g. So, weight of heavier body minus weight of smaller body by sum of two masses. That is 5 plus 3, 8 kg. So, 8. This is our answer. 5g minus 3g means 2g. 2g by 8 or g by 4 meter per second square. This is with the formula. Tension 2 m1 m2g by m1 plus m2. So 2 m1 m2 by m1 plus m2 into g. So what this is 2 into 5, 10, 10 into 3, 30, 30 by 8 g. That means this is 15 by 4. So tension is 15 by 4g Newton. And both are over. Finished. Now I'll tell you how to do it with equations also. Okay, check. Now values are given. So how can we do that? See now. 5g tension going down here. There is tension here. This is 3g. It's going up. Okay, let's write the equation. 5g minus t equal to 5a. Then here t minus 3g equal to 3a. T is cancelled. 5g minus 3g, 2g equal to 8a. A equal to 2g by 8 or g by 4. Same thing. Then tension. Now this value of acceleration I am going to put in this one. So 5g minus g by 4. Sorry, tension we are finding. 5g minus t equal to 5a, which is g by 4. So tension equal to 5g minus 5g by 4. That is 15g by 4. Check. So like this. If you forgot the formula, still you can do it fast. No problem. But if you remember the formula, you are getting the answer even faster. Is this clear?
Yes, sir.
Okay. Note it first. Completed?
1 minute, sir. Done, sir.
Yeah. Okay. So let's go for another question. Now this time question is this is a pulley. Here is one mass. Here is one, and there is another one. Like this. This is, let's say, 10 kg. This is 8 kg. And this is 4 kg. Okay. Now in this one, there are two strings. One is this one. Another one is this one. Okay. So now two tensions are there. So our question is, find tension in two strings and acceleration of masses. And acceleration of masses. That's our question. So note it.
Done, sir.
Okay. So now tell me that who is going to pull and who is going to follow? Is 10 kg going to pull it? Will it go down? Or these two together will go down? What do you think?
The 8 and 4 will go down.
8 and 4 together will take it down. Okay. If I say 10 kg is going down and we start solving in that way, any problem is there? No problem. We can solve 10 kg also. Only thing is, acceleration, whatever we are getting, will come negative. That means the direction we took was not correct. It is in opposite direction. That only will happen. So even if you did it do in the wrong side, don't feel that you are going to get the wrong answer. You will get the correct answer only. Okay. So fine. Now this is the heavier side. So we are assuming that it's going down. And all will go with the same acceleration because all are connected together. Okay. So acceleration of this is down and acceleration of this is upwards. Okay. Can I take this as a 12 kg and solve it? We can. We can. Both are going to move together. Both are going to move downward. Okay. And if you want to take them separately also, that is also okay. So both I'll tell you. But first, let me take them as one mass. So 12 kg. Here is 12 kg. And here is 10 kg. This is 10 kg. Okay, something like this it is. And here is one pulley which is connecting. Okay, so acceleration we know. If we directly I'm going to write the formula, I can. Heavier weight minus smaller weight by the total mass. That means 12g minus 10g by 12 plus 10. 12g minus 10g means 2g. 2g by 22. That means acceleration is g by 11. Done. Over. Okay. Can I solve tension with 2m1 m2 g by m1 plus m2? That will give me one tension. For that tension, I have to write the equations. Okay. We can do here tension if we have to find. We can get it with that formula of ours. What is the formula? Formula is 2m1 m2 by m1 plus m2 into g. So we will get the answer 2 into 10 into 12 by 22 into g. So this is 11. What we are getting? 120 g by 11. Okay. Now half the question is over. For tension in this one, I have to make the free body diagram and I have to write the equation. There is no other way. Okay, so first note this one. Completed?
Yes, sir.
Okay, let's go for 4 kg now. So 4 kg is free body diagram we have to make. There is a 4 kg here. Okay. Weight is acting down, which is 4g. And here, there is a tension. The tension is there upwards. And where is this 4 kg going? Down. With acceleration A. And acceleration A also we know. So write the equation. 4g minus T1 equal to 4A. Okay, so T1 equal to what? T1 will go this side, 4A will come this side. So 4G minus 4A equal to T1. Put the value. 4G minus 4, acceleration value G by 11. Okay, so 4G minus 4G by 11. 4G you take common. 1 minus 1 by 11. That is 10 by 11. So tension will come 40G by 11. Okay, you calculate that. T1 will come 40G by 11. Here is tension T1. T1 is 40G by 11 Newton. Is that clear? If any doubt is there, ask.
No doubt, sir.
Okay, note then. Completed?
Yes, sir.
Okay. Now let's see another format. Okay. Another format is if I am going to place the block on the table. There is a table like this. We are keeping one block here. And this is connected with a string. Here is a pulley. And there is one more block. Now it's acceleration and tension we have to find. So suppose I give here 10 kg and here let's say is 5 kg. Question as usual, find acceleration of two blocks and tension in the string. Okay, find acceleration of two blocks and tension in the string. Note the question. Can we apply the same formula in this one also? M2 minus M1 G by M1 plus M2 is the acceleration. 2 M1 M2 G by M1 plus M2 is the tension. Can we apply? No, we cannot. Why we cannot apply? Because in that system, both the blocks were hanging. So you took weight of both. But here both are not hanging. This is not hanging. It's on the table. So its weight is not making the body to move. Or its weight is not going to make body to oppose the motion. It's not. So that's why that formula will not work here. Then what to do? Then we have to solve it with equations. We learned how to write equations, so we have to solve it with equations only. Okay. Let's see then. Weight of this 5G. Okay. Tension is here. Now this can move downwards. So its acceleration is A. Okay. Same way now this tension, this string is over here at this point. Tension is like this. Okay. And this tension will make this body to move in this direction with acceleration A. What about its weight? It's already balanced. Who's balancing it? This table is balancing it. Okay, normal contact force is there. That normal contact force is balancing 10G. So we are not making it because it's not moving in vertical direction. So no need to make those two forces. Okay, only forces which are responsible for its motion, we have made it. So tension is here and it's moving with acceleration A, here 5G, here T. Let's write the equations. So resultant force for 5 kg is what? 5G minus T equal to 5A. That's all, over. For 10 kg, only force is acting is T. So T equal to 10A. Done. Now this T I'm going to put here. So it is 5G minus 10A equal to 5A. So 5G, this will go there, 15A. So A equal to 5G by 15, that is G by 3. Okay, acceleration we got G by 3. Now this acceleration I'm going to put here, T equal to 10A. So 10 into acceleration is G by 3. G by 3. Okay, so tension is 10 by 3G Newton. That's all, over. Is this clear?
Yes, sir.
Is anyone having doubt that how lighter mass is going to pull heavier mass? Is anyone having doubt like that?
No, sir.
Good. You asked how or no?
No doubt, sir.
Good. Even then, what it is basically, why it's possible that the heavier mass is able to pull 5 kg? The reason is because it's placed on the table. Okay, it's placed on the table. Its weight is not opposing us. If this would have been like this, sorry, it would have been like this, and here is 5 kg, and here is 10 kg. Was it possible for 5 kg to pull it? Answer is no. 10 kg would have pulled because its weight is acting. Okay. And its weight is more than the weight of 5. But in this case, is weight responsible for the motion? No, because weight is already balanced by a normal contact force. So in this case, there is no force which is opposing the motion. There is no force in this direction. This force is 0. Friction we have not studied yet. Friction will come, then we'll say that, okay, there is friction. But at the moment, no friction, it's a smooth surface. So because of that reason, there is no force which is opposing the motion. So this tension is able to pull it. Or rather, 5 kg is able to pull a heavier mass. Not only 10 kg. Even if I keep 100 kg also, that will also move. 1000 kg also will move. A 5 kg block can move 1000 kg also on smooth surface if it's kept on the table. Understood that?
Yes, sir.
Okay. So write that in your notebook and then we are moving ahead. Done?
1 minute, sir.
Okay.
Done, sir.
Right. Okay. Let's frame another one. Another question is, this is a table. Here we'll keep one block. This is connected with the pulley, and here is one block. Same way on the left side also. This is pulley, and here is another block. Okay, the system is like this. Let's keep the values of them. This is 3 kg. This is 5 kg. 2 kg. There is no friction anywhere. Okay. 2 strings are there. What are 2 strings? One is connected with 5 kg and 3 kg. Another one is 5 kg with 2 kg. So 2 strings. So find tension in 2 strings and acceleration of the system or acceleration of the blocks. Okay. Make the diagram. Done? Yeah. Tell me now in which direction, who is the pulling force? 3 kg is pulling or 2 kg is pulling?
3 kg.
3 kg is going to pull. So if 3 kg is going to pull, I can say that acceleration will be down. Okay. Let's make it. This is 3g. And here tension is at T1. Okay. Now let's go to 5 kg. Let's make its free body diagram also. So this is T1. We know that in this string tension will be T1 only. So at this point tension is T1. And since it's going down, so that means 5 kg will be going towards right. So its acceleration is right. Fine. Now, here is again spring, different spring, so different tension. But where will be the tension? Will it be left or will it be right? At this point. Where will be tension? Left or right? Tell me.
Left.
Say again.
Towards left.
Towards left. So here is T2. Okay, done. 5 kgs diagram is over because we know that its weight is already balanced by normal contact force, so we don't have to make it because it's not responsible for motion. Okay, so here comes the tension T2 and here this is 2G and here tension is upwards, that's T2 and its acceleration is like this. Done. Mostly the work is done. Already we have made the free body diagram. Now just we have to form the equations. So equation for this one, resultant force 3G minus T1. So 3G minus T1 equal to 3A. Here resultant force T1 minus T2 equal to 5A. Here resultant one T2 minus 2G equal to 2A. These three equations we have to solve. Now these three equations solution I am giving it to you. Come on, solve it fast. What's coming? Yes, students, what are you getting? See, answer I have written on the board. Are you getting the same?
Yes, sir.
Acceleration is g by 10. If you keep g value as 10, we are getting acceleration is 1 meter per second square. then T1 is coming 27 Newton and T2 is coming 22 Newton. Is everyone getting the same? First is add these three equations. Add them. When you add them, you can see minus T1 and T1 plus T1 gone. Minus T2 and plus T2 gone. What is remaining? 3G minus 2G. So 3G minus 2G is what? G. Equal to addition of this. 5 plus 3, 8, 8 plus 2, 10. So A equal to G by 10. I have written that. After that, this acceleration value put in the first equation. So 3G minus T1 equal to A value is what? 1. So 3. 3G means 30. 30 minus 3 equal to T1, 27. I have written that. Same way, this T1 value you can put here or here. Here. So then 27 minus T2 equal to 5A. What is A value? 1. So 5. So T2 is 22. That's all. It's over. Is it clear?
Yes.
Okay. Shall we move ahead?
Yes, sir.
Okay. So let's go for the next. Okay. So now we are going on the inclined plane. Okay. Inclined wedge or inclined plane. Similar kind of questions. First we did vertically, then we did on the horizontal. Now we are going on incline. Incline means something like this. This is theta here. Let's say a block is here, M1. Here is a pulley. And here is another mass. It's like this. Okay, and it's fixed. This wedge is not moving anywhere. It's fixed. So the question asks is a similar thing, tension and acceleration of the system. Okay. Find tension in string and acceleration of blocks. Tension in string and acceleration of blocks. Right. How to do this? Again, method is same only. Method is not changing. But because it's a different kind of a system, we have to see certain changes are there. So first is make free body diagram. Free body diagram says weight is acting downwards and there is a tension. And if we assume M2 is heavier and say that acceleration is downwards, it's like this. Then this is the same string, so tension will be same. Now, M1G is acting in this direction actually. So M1G is not going to pull it downwards in this way. Which force will pull it down? Remember that. What force? Sine theta. Sine theta is here. Okay. And cos theta is here. This is M1G cos theta. And this M1G cos theta is already balanced by normal. So I'm not interested in that at the moment, because that's not involved in motion. M1G sin theta does involve in motion. So M1G sin theta we have made. Acceleration A is upwards. Is this M1G sin theta, M1G cos theta clear to everybody? Or shall I make and tell you?
Understood, sir.
Good. So M1G sin theta is here, M1G cos theta is here. Now let's make the equation for them also. First for this block, then for this block. So first for this block again, what is the resultant? M2G minus T So m2g minus t equal to m2a. Here t is greater, so t minus m1g sine theta equal to mass into acceleration. So t minus m1g sine theta equal to m1a. Both equations we have written. Solve them, or rather add them. So minus t plus t cancel. So what we got? m2g minus m1g sine theta equal to m1 plus m2 into a. So acceleration we are getting is m2 minus m1 sine theta by m1 plus m2 into g. This is acceleration. Same way, what about tension? This acceleration value we have to put in this one or this one. Okay. So suppose I am putting it in second one here. So t, this one go that side, m1g sine theta plus m1a. Okay, m1 you take common. G sine theta plus a, and a is this. So I'm multiplying this, okay? m2g minus m1g sine theta by m1 plus m2. We have to solve this. Okay, first you note this, we'll solve it and get the answer then. Any doubt so far, whatever I have done?
No, sir.
Okay, great. Note it. Completed?
1 minute, sir. Done, sir.
Okay, get the value of t, solve this one. Everybody solved it. Take LCM and solve. Are you getting this? Check. Are you getting the same answer? Students, are you getting the same answer or shall I solve?
So shouldn't that be M1, M2, G1 plus sin theta?
Say again, M1, M2G. Yeah, that is M1, M2G. That's correct. Because this M1 is there. So that's a mistake from my side. Okay. That was only confusing you.
Yes.
Okay. So then everyone is getting this answer?
Yes, sir.
Okay, great. Let's go for the next now. Now this time we'll be connecting two blocks along the incline. So here it is. Block number 1, block number 2, and here is the pulley, and here is another block. Let's say this is 3 kg, this is 5 kg, or okay, let it be 5. 3 kg, 5 kg, and what shall I take? 8 kg. Okay. Find tension in two strings. Here there are two strings. One is this connecting 5 and 8, another one is connecting 5 and 3. And this theta, take as 60 degrees. Okay. Find acceleration of blocks and tension in strings. Now, so far I was telling you two strings are there. Now I'm not telling. You have to identify. Okay. So find acceleration of blocks and tension in strings. Now, this is a question for you people. Okay. And how much time shall I give you? 3 minutes? Or 4 minutes? Tell me. How much time you want? Your time starts now. Where shall we keep? Here. Timer has started. Come on, start doing it. One minute is over. 2 minutes are over. Okay, in the meantime, what I'll do is I'll start doing it, okay? Now I'll explain you. Oh, 60 degrees is going to create problem. Okay. All right. Have you completed? 5 minutes are getting over now. Okay, see on the board. Okay, it's a similar question to what we have already done. Okay, first we did in the case of vertical when 3 blocks were connected vertically. Similar type of question we did. Then we connected the same thing with horizontal also. Now in incline also. The first thing is consider these 2 blocks as one and solve it. This is also 8 kg, this is also 8 kg. Solve it. So make the equations. This is 8g, this is t. So we'll write 8g minus t equal to 8a. Here t, and here is sine component we know. So 8g sine 60. So t minus 8g sine 60 equal to 8a again. I have written the equation. Add them. T gets cancelled. 8g minus 8g sine 60 equal to 16a. 8a plus 8a. Okay, 8g I have taken common. 1 minus sine 60 equal to 16a. With 8, I cancel the 16, that is 2. So acceleration is g by 2 into 1 minus sine 60. Sine 60 is root 3 by 2. That's acceleration. That's all, finished. Now, tension. So this is the equation for me. This is here. So T equal to 8g minus 8a. And I put acceleration value and solve. I got this one. Still one more thing is there I have to find. Tension between these two. We can do that. For that 3 kg free body diagram I'll be making. Let's see then. And here is 3 kg. In this direction, there is a force 3g sine 60 acting. and here will be some tension T1, and its acceleration we already know. So if I write equation, it says T1 minus 3g sine 60 equal to 3a, and a is here, which you already have got. So T1 is, take this 3g sine 60 that side, plus 3 into a, that's g by 2 into 1 minus root 3 by 2. Sine 60 also you keep the value, root 3 by 2, it will be better here itself. So root 3 by 2. Now solve. Now this is 3 root 3 g by 2. Multiply this inside. Okay. 3g by 2 minus 3 root 3 g by 4. You got the answer. Okay. What is the answer? T1 value. Now 3 root 3 g by 2 minus 3 root 3 g by 4 will be 3 root 3 g by 4 only. So 3 root 3 g by 4 plus 3g by 2. That's it. Over. For the simplifying, you can take 3g by 2 common and root 3 by 2 plus 1 will come. That's also okay. Did you understand?
Yes, sir.
Okay, note it. If any doubt is there at any place, ask. At any place, any doubt is there, ask me. Okay, then note it. Completed?
1 minute, sir. Done, sir.
Okay. So see that this one type of problems in all the things we have done, vertical, horizontal, and inclined. Now I'm telling you a different kind of a problem in which connection will be slightly different. How is the connection? See. It's like this. Okay, this way connection is given. Suppose masses we can take you can take this as 4 kg and this one 5 kg or 6 kg. And then the question is asked from us. Find tension and find acceleration. Okay. Find tension in string and acceleration of the blocks. So two strings are there. One is this, you see. This is one, and this is the other one. So two tensions are there, two strings are there. Okay. Make this. Completed.
Yes, sir.
Okay. So let's see. We started making, or we started in the same way as we normally start this kind of a question. We made a free body diagram. We say 4G is here. Let's assume tension is T. Let's assume it's moving downwards. I'm just assuming it. I don't know whether it goes down or not. Just make it's going downward. Here tension is also upwards. Here is also upwards. So this much I could make. Now here is a pulley. And under pulley there is one spring. So it's like this. There is a pulley here. Here is tension T. Here is tension T. And here downwards is tension something T1. Okay. Pulley is massless. Pulley is massless. So if I write equation for pulley, whether it's going down or it's going up, whatever, in any of the case. If suppose I take it as moving upwards, it's going up. So I'll be writing equation for that. It will be 2T upwards minus T1 equal to mass of the pulley into acceleration of the pulley. But mass of the pulley is 0 because it's massless. So what do you write? This is 0. So that is 2T minus T1 equal to 0. That means T1 is what? 2T. Okay. T1 value is 2T. So okay. So that means here tension will be 2T. Perfect. Because we got it. Okay. So here tension is 2T. So far, we got this information. Now the question is, still now, whatever questions we did, the string which is connected to two blocks, okay, single string used to be there, and tension in the two blocks used to be same, right? Here also, there is a single string which is connecting this pulley and this block, okay? And in this block, tension happens to be double of this one. And here there are two pulleys. So in these kinds of a question, what we need to do? We have to get the acceleration of these two. Their acceleration is not same. I cannot say its acceleration is A. Okay, it will not be. It has got some other acceleration. So we have to find that acceleration. You write here 6G. Okay, and let it go upwards. There is no problem in that. But here acceleration and here acceleration is not same. When tensions are different, tensions involved in moving the blocks are different, then we need to think about constraint equations. Okay, there is equations called constraint. Writing here. It's easy, okay? No need to worry about that something different is coming. No, it's very easy. I'll tell you in easy form. Don't have to go in another form. When to use constraint equation? Whenever you have more than one pulley, so immediately that thing should go into your mind. Then, after having more than one pulley, if you find that there are two blocks and both the blocks are moving with a different tension or different tensions are involved in the two, immediately you should think about it. Okay, what to think? Constraint equation. Now, how to solve it? Very simple method. Just see that what I am doing. Only we have to talk in terms of tension over here. We are not going to talk about any other force, only tension. So here you see tension is upwards and acceleration is down on this 4 kg block, which is a moving block. So just write minus T into A. Why minus? Because both are in opposite direction. Minus T into A. Plus, check here. This block is also going to move. Yes. Tension in this one is 2T and its acceleration is A1. Both are in same direction. So 2T into A1 equal to 0. That's all. Nothing more than that we have to do. So what is there then? 2T into A1 equal to T into A. You took T in that direction. So T and T gets cancelled. You got A1 value. What is A1 value? It is A by 2. Now I can solve this question. Now I can solve this question very easily. Otherwise, it was impossible for me to solve because I was not knowing with what acceleration it is going. Okay, there is no other method. You have to apply constraint equation. Constraint equation, how to find this relation? There are many methods. Okay, there are many methods. At least 3 methods are there. But I have told you the easiest one. Okay, what we have to do? The product of tension and acceleration. Minus T into A. Why minus? Because acceleration is down and tension is upwards. Plus product of this. Tension into acceleration. They are in same direction. So 2T into A1 equal to 0. Make them equal to 0. And then you are getting A1 equal to A by 2. Okay. Now I'll be writing its equation. So its equation is how? Just see. That equation is 2T minus 6G equal to 6A1, which is A by 2. Okay, put that. 2T minus 6G equal to 6A by 2. So this is 3. 2T minus 6G equal to 3A. Another equation what we have there? We already have found? No. This equation also we'll write. So this equation is 4G minus T equal to 4A. Now I'll be solving this and this. 2 equations I have, I'll be solving that. So put it over here. 4G minus T equal to 4A. We'll be solving this. But before this, copy what I have done. And any doubt anywhere, immediately you should ask question. Okay? Note it. Completed?
Yes, sir.
Okay. So let's solve this and get the answer. Finally, can you give me the answer? Come on, solve these two equations. You cannot directly add them because here tension is T and here is 2T. You have to solve it properly. Solve it and tell me what the answer is. Check what I am getting. Are you also getting the same? I am getting acceleration as 2g by 11. Are you getting the same answer?
Yes, sir.
Good. Then once you are getting acceleration, we'll be putting into this equation. So we'll be getting tension after that. So tension I am getting is 36g by 11. You also calculate and check. Are you getting the same answer? Don't see how I have calculated. Don't see that. You calculate and then match. Is it same or not? If it's not matching, tell me. I will also check. Okay. If you are going to see how I have done, then your answer and my answer cannot come different. So if I have done mistake, you will not be able to find. Do yours and check.
Yes, sir.
Okay, same answer, different answer.
Same, sir.
Okay. Completed everybody then? Students, have you done?
Yes.
Okay. Now, again, on one more question I am giving you on constraint. Okay. Let's do that also. Okay. So let's try and frame that. All right. This one you take as what? 5 kg. And this one 10 kg. Okay, find tension and acceleration. Now this is question for you. This constraint equation is involved in this one. Decide. Is constraint involved? Is acceleration of these two blocks same or different? Think. The question should come in your mind. There are two pulleys. Okay. Then what we have to do? Immediately think about tension. Let's say tension here is T. We come over here, same string, so tension here also T. Same string, so tension here also T. So here is T, here is T. That means tension over here is how much?
2T.
How much? 2T. Absolutely. So here is 2T. Now see the tensions are different. Here tension T, here tension 2T. That means yes, constraint equation we have to write. We have to go for the constraint. So go for it. Assume its acceleration down. Let's say it is A. And its acceleration upwards, A1. Fine. What is the relation? Come on, that you are doing. Now I'll not do. Tell me what is A1 value in terms of A. Use constraint equation how I told you. Come on. Product of tension and acceleration for block 1 plus product of tension and acceleration for block 2 equal to 0. Okay. Product of tension and acceleration for block 1 plus product of tension and acceleration for block 2 equal to 0. So here, tension upwards, acceleration downwards. So, minus T into A. Here, tension and acceleration in same direction. So, plus 2T into A1 equal to 0. So, then T into A, we took this one that side, equal to 2T into A1. T gets cancelled. A1 here also is A by 2. So this A1 is A by 2. Now we'll write equations. Simple now. Very simple. Now here 5G and here 10G. So let's write the equation. Here comes 5G minus T equal to 5A. Here 2T minus 10G equal to 10 into A by 2. That means 5G. 5. So 5G minus T equal to 5A. And here 2T minus 10g equal to 5a. Now solve. This is in your hand. Did you understand? Students, are you understanding? In the previous question, we did in the same way only, no? But let me go back, okay? I'm thinking that their acceleration, we did not took a by 2. No, we took it. Fine, fine. That's fine, okay? Right. Come on, solve. 2t minus 10g equal to 5a. Now, you tell me what are the acceleration and what is the tension. It's in your hand. Come on, solve it fast and tell me. Yes, students. What's coming? Yes, students, tell me what's coming. Don't hesitate. What happened? No one is responding. Still calculating. Say yes or no. Are you still calculating? My God, nobody is responding. Okay, tell me, shall I solve?
Yes, sir.
Okay. Whatever I have written on the board, in that one, any doubt is there?
No, sir.
Okay. So here we have 5g minus t equal to 5a equation. Here we have 2t minus 10g equal to 5a equation. We have to solve it. So what I thought is, let's multiply in this one with 2. And in this one with 1. 1 means nothing. So if I multiply in this one with 2, this equation will change into this equation will be 10g minus 2t equal to 10a. And the other equation is same, 2t minus 10g equal to 5a. I'm going to add. So when you are adding it, you see that tension is getting cancelled. This is 2t and this is 2t, but at the same time, 10g is also cancelled. 10g minus 10g, 2t minus 2t. So that means 0 equal to 15a. That means acceleration is 0. It's not moving. That means 5 kg is able to balance 10 kg. Yes. Why? That's the beauty of these two pulleys. 5 kg is able to balance 10 kg. Okay. Then what is tension? Acceleration is 0. Fine. A is 0. This obviously A1 is also 0. Tension is what? So I'm going to keep this equation is there. So let's put acceleration 0. So 5g minus t equal to 5a. That means 0. So that means tension is 5g. So in this one tension is 5g and in this one tension is 10g because tension is double. Did you understand? Is it clear?
Yes, sir.
Okay, note it. Completed? Completed, students?
Yes, sir.
Okay, so we'll have, that's all for today. Today you will be getting the worksheet. Okay, solve that worksheet. It will have few questions from this constraint also. If you are able to do, well and good. If you're not able to do, we'll discuss in our next class. Okay, but other questions, other parameters like what we discussed today and the questions we have done before, all the questions will be involved in that worksheet to solve constraint equations also, but I expect that constraint equations you will not be able to solve. So we will be solving it in the next class. Okay, next class on Tuesday. Is that okay?
Yes, sir.
Okay then. See you on Tuesday. Bye-bye.
Thank you.
Thank you, sir.
Thank you, sir.